Section 1.5, Angular Measurements. Earlier in the chapter, we talked about, for example, how latitude and longitude in space are called declination and right ascension, and that gives us very precise placement of objects in space. It gives us a way of giving their location very precisely. But how do you measure angles in space? That's a very important topic here. And so let's just start with this simple fact that when you talk about going from horizon to horizon, we all know that that would be 180 degrees. 180 degrees. So how big is a degree? Well, to give you some rough ideas, I'll show you a picture here in a second. But for example, if you hold up your pinky finger and you just stretch it out as far as it'll go, that's maybe about 1 degree. About 1. And if you take your fist and hold it up like this, you're up to about 10 degrees or so. These are obviously very rough measurements. I'll show you a picture of some different things that astronomers do. But that gives you some idea in degrees. And at least that's something we're all maybe somewhat familiar with. What would you measure with that? Well, really wide things in the sky, like maybe the length of the Big Dipper or something like that. So, but that's not what astronomers actually typically work with. They're actually typically kind of zoomed in on much smaller things in the sky. So what astronomers have done is taken one single degree and chopped it up, sliced it up into 60 smaller angles called arc minutes. And now if you remember my lecture on right ascension. Right ascension is measured in hours, minutes, and seconds instead of degrees. And I told you that historically the reason that happened was when ships were sailing east and west across the ocean, let's say from the new world to the old, from the old world to the new world, they didn't have a good way of measuring where they were at. Latitude you can get with the North Star, but longitude there was no signpost, no way to do that with the sky, and so they started doing it by time. Well, we sailed for 2 days to the west. Not a very accurate way to do it since your sailing ship is going to be going faster at some times and slower at other times, but that's all they had to go with. Anyway, that's how time got involved with all of this. So that's why we divide up a degree into arc minutes. 1/60 of a degree, that's a very, very small angle. So think of it, if you think of a degree as like an hour, okay, you can do the math very easily, because if I ask you how many minutes are in half an hour, everybody's going to know that. That's not a problem. So if I say how many arc minutes are in a degree, well, just think of it like the same as the math of hours, minutes, and seconds, and you'll be fine. Remember, we are dealing with angles. We're not dealing with time. I know that's so confusing, and I wish it wasn't that way, but that's how it is. So for example, the width of our moon and our sun are both about half a degree. Something we're familiar with, half a degree wide. But that would translate to 30 arc minutes. Think about that. If I say half an hour or 30 minutes, means the same thing, and all of you would understand what I meant. Okay? Well, guess what? That's not, the sun and the moon are two really big things in the sky, but astronomers are pinpointing things much smaller, and guess what? They take an arc minute, which is already a small angle, they slice it into 60 incredibly small angles, you can probably guess, arc seconds. So there's 60 arc seconds in an arc minute, or 3,600 arc seconds in a degree. Think about how incredibly small that is. In my classroom, we have a balcony right outside my classroom, and a field there. You see tennis courts and our garden, and then in the distance you see another school, a middle school. Well, if you kept going, I always tell my kids, if I went out and walked across the tennis court, across the fields, across that other school, and turned around and held up a dime, the width of that dime would be an arc second. From there, if they're standing on the balcony at the school and I've gone a mile away and I hold up a dime, now obviously they couldn't even see that dime, right? I mean, that's how small an arc second is. It's an incredibly small angle, and astronomers deal with this all the time. All the time with something called parallax. They're dealing with fractions of an arc second. It's amazing. So when we talk about the size and width of things in the sky, you're going to use degrees for things, again, like entire constellations, big patches of sky. And then you chop that down to arc minutes, and finally arc seconds. This brings up one of the things that's absolutely incredible about the Earth. That's just an unbelievable coincidence of nature. And that's the fact, look at that. I said that the sun and the moon are both 30 arc minutes wide, right? Why is that so? Well, it turns out that the sun is 400 times wider in diameter than the moon, but also happens to be, almost exactly 400 times farther away. That's absolutely incredible. That's why they end up being the same size in the sky. That's why an eclipse works the way it does, that the moon can cover the sun so perfectly. There's no reason for that. That didn't have to happen. And actually, it wasn't that way in the past. The moon used to be actually quite a bit larger in the sky. But the moon is slowly moving away. I forget what it is, half an inch per year or something. But over billions of years, the moon was much bigger in the past. And guess what? The moon is getting smaller to our perspective in the sky. The moon is getting smaller year after year. And so eventually we won't have total eclipses anymore. It's kind of sad. But anyhow, the fact that right now, at this moment in history, they're the same size in the sky most of the time, that's just incredible. So here's that picture I promised you, showing some of the angles, just little tricks of the trade. If you're standing out in a field with your friends and you want to tell them, hey, you need to go 25 degrees in this direction, so you hold up your hand like that. That's just kind of cool. And then here you have, just in case you were struggling to understand what I was saying, so here's a whole circle, one little slice, right? One little slice there is 1 degree. Now we take that light blue degree and take one little slice of it as an arc minute. And now we take that dark blue, wait a second, that dark blue line there, and now we're going to take one more tiny little slice. Imagine what a tiny slice of sky that is, and that's an arc second. So degrees, arc minutes, arc seconds, that's how we measure the width of things in space. Thanks for listening.